Hi everyone, and welcome to this 20-minute introduction to SQL. I'm Malvik Fagadia, and today I'm going to introduce you to the world of SQL, a language that's not only incredibly popular, but absolutely essential for managing data across virtually every industry. In this video, we'll cover what SQL is and run through some hands-on examples. SQL, or Structured Query Language as it's abbreviated, is the standard language used to communicate with databases. A database is an organized collection of data, while a database management system is the software that enables you to store, manage, and interact with that data using SQL as its language to perform tasks like querying, updating, and administering your data. Its popularity comes from its simplicity and wide adoption. SQL is essentially the backbone of data management, helping virtually every organization store, query, and analyze their data. SQL follows the ANSI standard, meaning that while each database management system might have its own extensions, they all stick to a common foundation. And this standardization is one of the reasons why SQL remains so essential and versatile. While there are many different relational databases and database management systems, I'll be focusing on MySQL for this demonstration. MySQL is one of the most popular relational databases out there. Okay, so let's jump in. What you see on the screen is MySQL Workbench. MySQL Workbench is a client tool that connects to a MySQL server. You configure it with the server's details, and then it provides a graphical user interface to manage databases, run queries, and design schemas on that server. Keep in mind that while various databases exist, each has its own development environment. For the purposes of this demo, I'm not going to run through the installation process for MySQL, but I will provide relevant documentation in the video description. The main window on the MySQL Workbench has several panels. On the left, you have the navigator. This lists your connections and your schemas. And the SQL editor is in the center. This is where you can write and execute your queries. I have some scripts here across 3 tabs, as you can see. All of the code used in these demos can be accessed via a GitHub repository, which I'll link in the video description. The first set of queries that I want to show you is related to data definition language commands in SQL. These are the commands that define and modify the database structure. So for example, this statement here creates a schema. It's pretty easy to read the statement. SQL is a declarative language. You describe what you want without detailing the steps. This is what makes it relatively human readable. And in MySQL, a database and schema are interchangeable terms. Database assets, such as tables, are contained within schemas. On the left panel here, we can see a list of schemas available to us. Currently, there's only one schema called sys, which is short for system. This is a system managed schema. So let me highlight this statement and then click on this lightning bolt icon, which runs the statement. Oh, and by the way, everything you see here with a double hyphen is a comment. So this line is treated as a comment and it will not get executed as code. It's ignored by the SQL engine. So let me highlight this statement and run it. So what you'll see is an action output if I drag this out, and you can see that that was successful due to the tick. So now all I need to do is refresh this, and we have a schema called demo. If I expand it, we don't have anything in it yet, but this is where you can store your database objects, such as tables, views, stored procedures, and functions. This next statement below creates a table called countries. The dot notation here, demo.countries, specifies which schema the table should be stored in. So I want to create a table called countries in the schema of demo. So the syntax is create table schema.table name. And then inside of this parenthesis here, we're defining the structure of the table, such as the columns that the table should contain. We have the column name here, and then we specify the data type of the values that the column can hold, and then any additional constraints. So for example, this column, country ID, can only store integer values, as you can see. And it's got a primary key constraint, meaning that each value in this column must be unique and not null. In SQL, null represents missing, unknown, or inapplicable values. It's not the same as 0 or an empty string. It rather indicates that no value exists. And then for this name column, it is of the type varchar, which is a variable length character up to 100 characters. And as a constraint, I've specified not null, meaning that this column cannot store null values. And then we have continent code. This time, the data type is char, which means that it can only contain values of fixed length string of 2 characters. And as a constraint, it cannot take null values. We also have the population column, where we specify a data type as integer, but no constraints. So this column can hold null values. So let's highlight this statement and create the table. So notice we don't have any tables in this demo schema yet. So let me run this. And this tick indicates that it's successful. And now upon refresh, we can see the table here. It's currently empty and holds no values, but we can see the structure. Here are the columns that we've defined. So now let me run this statement, which creates another table called continents. And that contains 2 columns, continent code and continent name. And that's also worked. So now let me refresh. And here is the continents table. Here are the 2 columns that we've defined. So I hope it's clear that to create database objects, we need to use create statements. We can also alter database objects. So for example, this statement here is altering the table countries in the demo schema and renaming the column called name. So here is the column name to country name. So let me run this and then refresh and watch what happens here. This changes to country name. We can also delete database objects. We do that using this drop table statement. So this will drop the table continents. So notice here's the table. Now when I run this statement, it's gone. But I want to keep that table, so let me run this statement which creates it again. And now here it is, continents. So create, alter, and drop statements are data definition language commands. They're commands that can define or modify the database. There are other commands that fall inside of data definition language, but these are the ones that I wanted to show you for this demo. So moving on, we also have data manipulation language. These statements manipulate the data within the database. They can do things like insert data into a table, update that data, or remove records from the table. So this statement here inserts 10 records into the countries table. It uses an insert into statement. I'm specifying the target table where I want to insert the records. So I'm qualifying the schema name as a prefix to the table name. This sets the context for the SQL interpreter, so it understands which table in which schema I'm referring to. Inside of the first set of parentheses, I'm specifying the columns in which the data will be inserted. Country ID, column name, continent code, and population. The values clause then lists multiple sets of values. Each set corresponds to a new record. So this is one record, this is another record, and so on. So they're all separated by commas and enclosed in parentheses. So 1 gets inserted in country ID, United States gets inserted in country name, NA for North America is the continent code, and 331 million is the population. So this specific example, so this statement, is inserting multiple rows. This is known as a multiple row insertion. So let me run this. So that's worked. We can see from this action output that 10 rows have been affected, and that is because we've inserted 10 rows into this table. So the code below is also inserting data, but this time into the continents table, and it's using a different approach. This time we have multiple single row inserts. Unlike a multi-row inserts, these statements are written so that each one inserts a single row into the table. So we can execute multiple statements at the same time, and this is where the semicolon is very important. This indicates the end of a single statement. So this is important. Otherwise, it would treat everything as one long statement and you'd get a syntax error. So let me highlight all of this and run this. So now as you can see, this time from the action output, each statement has got its own separate action. That is because each statement was executed separately rather than as a single operation. Now, if you recall, when we created the table, we provided specific constraints. So for example, this continent name column cannot contain null values. So if I try to execute this statement below, where I'm inserting a null value, so this represents a null value, into the continent name, we should get an error. Let's test that. And we do. And we also get the error code here. Column continent name cannot be null. So that constraint has worked. This is an example of database schema enforcement. A database management system ensures that the data stored in a database adheres to a defined structure or schema. Okay, so before we move on, let me clarify that data manipulation language isn't just about inserting data. You can also update and delete data as well. Great, so let's move on to data query language. So as you know, these tables in the demo schema, continents and countries, have now got data inserted into them. We can analyze this data, and we can do this via data query language commands. These statements are used for querying and retrieving data from the database. Basically, any statement you see with select in front of it is a data query language command. Data query language is predominantly used by data analysts and business intelligence professionals. These personas rely on DQL, particularly the select statement, to retrieve, explore, and analyze data from databases, helping them generate insights and drive decision making. Okay, so to retrieve data from this countries table in the demo schema, I can use this statement. And once again, everything you see here should be treated as a comment. So just like the 2 hyphens for single line comments, I can write a multi-line comment using this bracket asterisk syntax. So anything enclosed between this bracket asterisk asterisk bracket is a multi-line comment, and it won't be executed as code. But regardless, if I just highlight this statement, then I will only run the statement that I've highlighted. So what does this query do? This query retrieves every column and every row from the demo countries table. In other words, it displays the entire data set within that table, provided it consists of less than 500,000 rows. So this select keyword starts the query and tells the database that you want to retrieve the data. The asterisk is a shorthand that means all columns. So it essentially instructs the database to return every column in this countries table. And then this keyword specifies the source of the data. So the source of the data is from this table. So this is the source table. So let's execute the statement. So that's worked. And notice a result grid pops up. And here is the result of the query. If we want, we can also export these results in a format of our choice, such as CSV. Okay, so now similarly, this statement should return all of the columns and all of the records from the continents table in the demo schema. Let's run that query. And here are the results, as you can see. And then moving on, we have another query. This statement shows that the formatting of the query doesn't matter. The SQL interpreter ignores extra white spaces, so you can have your query split across multiple lines. And in this example, I'm not only specifically specifying which columns I'd like to select, but I've also formatted the query so that it's easier to read. And rather than using the asterisk wildcard to select all columns, it should retrieve only the data from the country name, continent code, and population columns. So let me highlight it and run that query. And as you can see, that is the case. We only return the country name, the continent code, and the population. Okay, so now this next query is very similar. but it's doing something called aliasing to rename the columns in the result set. So country name is aliased as country, and you do that with this as keyword. Continent code is aliased as continent. So let's execute this query. So as you can see, the result contains country and continent rather than country name and continent code. This renames the columns only for this result set. The underlying column names are still the same. This next query shows you how to filter your data. You can filter your data using this where clause. After the where keyword, you specify a condition. Only the records that meet this condition will be displayed. So only where this condition is true will the records be displayed. So let's say I wanted to filter only records where the population is greater than 1 billion. Well, this would be the condition. So if I execute this query, we can see that in our result set, all of the populations should be greater than, so I believe this is actually 100 million, not 1 billion. So all of the records have a population greater than 100 million. And now this statement below performs an aggregation. So this is summarizing the data. It retrieves the total population, which is the sum of the population column, by continent code. So it retrieves the total population for each continent by summing the population values in this countries table in the demo schema, grouping the results by the continent code. So notice the use of this group by clause. So let's execute this. So this summarizes the data. Each continent code is distinct, and we get the total population for that continent code. And now finally, this last query is combining the data from two tables. It's combining the countries table and the continents table. So before I explain what this is doing, let me run these top two queries at the same time. So to run multiple queries, you can just highlight everything you want. And like I said, these comments will not get executed as code. So only this statement and this statement will get executed. So let me run that. So we have two tabs. This is the result of the first statement, and this tab is the result of this second statement. So the countries table here doesn't have a continent name, rather it has a continent code. And this continents table has a continent code which maps to a continent name. So we can perform what's similar to a VLOOKUP on Excel to return a single result set, which consists of the country name and the continent name and the population. And that is what this query is doing. So you do this with a join operation. So the query is joining two tables. It's joining the countries table to the continents table. It's aliasing the countries table as T1, so I could do as T1 like this and as T2 like this. It then retrieves the country name from table 1 and it aliases that as country. It retrieves the continent name as continent from table 2 and the population as population from table 1. The join condition is where the continent code of both tables is the same. So this is really like SQL's version of a VLOOKUP. So let me run this. And here are the results. So we have the country, which has been mapped to a continent, and the population. So this column is from the countries table, this column is from the continent table, and this column is from the countries table. Okay, so in summary, we've covered some of the core SQL query clauses. We've covered select, we've covered the where clause, we've covered group by, and we've covered joins. These help you retrieve, filter, aggregate, and combine data from your tables. But there's much more to SQL than writing basic queries. You need to understand how clauses interact, the order of execution, and the nuances of the syntax. If you're ready to go deeper, then check out my comprehensive SQL course on Udemy. With over 9 hours of hands-on lectures and real-world projects, it's designed to give you practical experience and a solid foundation in SQL. If you're interested in enrolling, then check out the links in the video description. There's a special link that will apply a significant discount. So as one final note, I won't cover them, but in addition to data definition language, data manipulation language, and data query language, there is also data control language commands that manage permissions and access rights, as well as transaction control language commands that handle and control transactions within the database. Okay, so that brings us to the end of this tutorial. We've explored what SQL is and some practical examples using MySQL Workbench. Thanks for watching, and if you enjoyed this video, then please like, subscribe, and leave your questions or comments below. I'll see you in the next video.